Hello, and welcome to this edition of EMS Now Up Close. I am Eric Miskell with EMS Now, and my guest today is Claire Hotvedt. She is the Senior Product Development Specialist with Indium Corporation. Everyone, of course, knows who Indium Corporation is. They are literally the glue that holds everything together in this industry. But Claire, thank you for taking time to speak with me today. It's my first opportunity to interview you. So why don't I just begin by allowing you to introduce yourself and tell what your role is at Indium.
Thank you, Eric. So as you mentioned, I am a senior product development specialist, and I personally love this role because it does mean I get to focus on some of our newer, more innovative products in the solder paste line. This includes everything from low temperature to what we'll be talking about today, to higher reliability developments, and working closely with not only the R&D team, but also the customers and sales team members that are solving brand new problems and bringing solder paste into these spaces.
Yeah. And so just for curiosity, how large is the R&D team then at Indium? And are you all located up in New York there, or?
The vast majority of the team is in upstate New York. We have both a team of metallurgists and flux chemists based in Utica and Clinton, New York, in addition to some R&D team members abroad in China at the time. So all in all, I'd say a good 20, 30 people are involved, and I love working with a lot of brilliant minds.
Yeah, no doubt, no doubt. Well, like you indicated, we're here to talk about the Durafuse LT, which is the low temperature. So tell me about that, and specifically, let's start about the role that the Durafuse LT has in sustainability.
Hey, thanks for asking about it. So Durafuse LT, the LT, if it wasn't clear, stands for low temperature. It's just an acronym, shortening it up for everyone. And it is a new technology developed and released in mass production as of 2020. And the goal is to bring down the temperature of the reflow ovens for SMT lines, building circuit boards. It was initially developed with kind of technical requirements in mind. There are people out there that can't go to higher temperatures for one reason or another. But increasingly, we thought sustainability is becoming so important, not only to governments and due to regulation that's coming from the EU and their energy efficiency directive. It's coming from China, and I believe they've required a 15% reduction by 2025. That's coming soon. But also the consumers and the large companies that are trying to improve themselves. And something that we've done recently, myself and in partnership with Heller Industries, is really taking a much harder look at ways the manufacturing process itself can be improved to reduce energy and therefore increase sustainability and reduce carbon emissions. Durafuse LT and dropping that reflow temperature has a surprising impact in this space. You wouldn't necessarily think it. You're just decreasing the energy a bit, but the average person doesn't realize just how much energy a manufacturing process requires.
Yeah, and I think people probably think of the other ways to improve sustainability outside of the line, right? What do you do with your facility? How do you do that? And with your, the transportation and all the logistics involved. But this is, like you said, probably an overlooked but significant piece of that.
Very much so. I mean, some other applications and changes out there, large companies might change their HVAC system and reduce energy by that means. Yeah. Or maybe you say, we're going to try to get our energy from a solar plant, which is amazing. That is also a huge investment and challenge to be done effectively across the globe. And in other cases, there are smaller changes that can occur, such as changing light bulbs and overall shifting your process to be more efficient.
Mhm.
But what I don't necessarily think someone would realize off the bat is a single oven will consume much more energy than the standard household in the US. And so if we're able to reduce 10% of that energy, we can start moving the needle in a big way.
Mhm.
And many of these sites will have at minimum 5 ovens, but large ones will have 20 or 30.
Wow.
And that's where it adds up to be on the same scale as those, as an acre of solar power panels.
Yeah. And as you indicated, you referenced Heller there. So you obviously you're engaging with the those who are making those big ovens and speaking to them in that. Is that an important contribution and consideration?
Yeah, so recently I published a paper with Heller in Apex 2023. That's why I brought them up, is they were directly involved in that paper, but they are not alone in some of these oven manufacturers in improving and considering energy consumption, both for with their own methods and now working with us as solder suppliers.
Yeah. No, that makes sense. So that's good to hear. Now, you reference it for some people, they just can't do the high temp. So hasn't low temperature solders really always been there? Haven't they? They've been around, right? So
that's totally true. So going back into the mists of time, though not too far for some people, tin lead is a solder that has a lower temperature than our standard industry SAC 305. And that is an example of a material that was set aside for different environmental concerns. But when new solder alloys were being explored, you have, in addition to SAC 305, there's also an existing suite of materials that are near eutectic bismuth tin-based solders. And these are very effective in their select applications. Bismuth tin melts at about 140 degrees Celsius, and you can reflow at around 170. However, there are some very serious reliability challenges, which are why we don't currently use bismuth tin low temp solders in most applications to this day. If you drop something, you want to make sure that solder joint holds strong.
Mhm.
And the bismuth tin solders, unfortunately, for many applications, are very brittle. One of the first places actually we got to use Durafuse LT, which reflows at 200 degrees Celsius. That's about 40 below SAC 305, is in the cell phone industry, because cell phones get dropped a lot. And I'm very much guilty of it. I'll raise my hand first. You don't have to.
Thank you.
And so because cell phone is one of many applications that has to deal with drop or impact, if they want to add complexity or maybe cutting edge components into the design that aren't capable of reflowing up at SAC temperatures, then using bismuth tin would be a big compromise in terms of their lifetime and reliability. So it doesn't matter if the screen lasts, if at the end of the day, you've got a very shiny, expensive rock in your hand. The electronics are important.
No, exactly right. But so it sounds as if now there's an opportunity, and you guys obviously were jumping at it, that now seems to be the right time for a variety of reasons to be promoting the Durafuse LT.
I 100% agree. As I think I mentioned briefly earlier, our initial goal was to combine low temperature with reliability for technical reasons, because there are applications out there that maybe because in cell phones, they need to stack many different pieces together. And that means they need to do things at different temperatures, sometimes SAC, sometimes lower, and manage that. But increasingly, there's also brand new components that warp and change or sensitive to high temperature oven conditions. And those are another place where lower temperature is valuable. So that was our first interest, is we see miniaturization happening. We see new components coming onto the market. We're like, okay, you need these You need to handle these challenges, but survive drop.
Mhm.
Needs to survive. And you need reliability. What had happened for a long time is people had talked about energy saving. That's a nice side benefit of having a low temperature alloy. But we hadn't really crunched the numbers to put it on paper. So someone sitting at the factory can make an ROI, can evaluate, hey, where is the real value of reducing the temperature of the ovens? And if you don't have those metrics in front of you, it's, again, it'll say that nice side benefit. And in the modern day, just looking at the cost of energy increasing, especially in Europe, and in addition to people's increasing awareness of sustainability and looking for different avenues to reduce their carbon emissions, I believe we really had to sit down and quantify and understand the impact we could have. And that's what we've done.
Yeah. So now is the time. It's for all of these reasons, it's coming together. But I guess the question is, with the benefits that it provides, why isn't it more common?
Well, to be fair, it's only, well, it's now 3 years out. It's 2023. Okay. So it is new. Currently, I said cell phones were the first because of technical requirements, but moving quickly into some of these large boards that have warpage challenges. And now, as after we've acquired this data and this research, sustainability is the next big direction. And I'm talking with several large players about the ability to reduce their, well, this would be their scope 1 emissions. So the way the sustainability mindset has been is initially when someone buys a product, at first the company had to report, okay, their scope 1 emissions. What are they actually emitting on their own as they sell you the product? But for them, scope 2 or 3 is their suppliers and how they're building and manufacturing the product. And for the end customer of a car or a television or a cell phone or a server, maybe the assembly house is including the reflow process in their initial emissions, but the previous stage when we're involved with solder wasn't getting looked at as closely. But now is the time when we are looking at that next stage, and the large players and contract manufacturers globally are now looking at their scope 1, their direct impact on sustainability, on carbon emissions and the environment. Yeah. And so I think that's part of the reason why now is different. It's because the focus has moved past that initial consumer interface into the industry itself, where honestly the bulk of the emissions are occurring.
Okay. As I hear you speak, I'm thinking about the benefits that should be experienced then by other equipment. We're talking ovens, but I'm thinking of like AOI people who are trying to catch the problems with it, right? This should be hopefully also alleviating some issues and by making it a better connection across the board.
Yeah, I think that ties into what I'd like to believe is a long-term goal of ours and our fellow equipment suppliers and partners to improve the efficiency of the process. Yeah. And improve the manufacturing process, because sustainability is very tightly linked to good manufacturing design and well thought out procedures and high efficiency. And that's good for everyone, right?
No, absolutely. Yeah.
So, and I think both on the art side, the oven's a new place, and that's maybe why we're focusing on it, because previously when we talked about profiling, there was no bandwidth with SAC to talk about reducing the energy, because the profile has such an impact on solder joints. You talk to any of my partners, my colleagues that do technical support, and they spend a lot of time understanding how to provide a good profile to make a solder joint consistently, time again. Less rework, less scrap is also efficient, as you say. What Durafuse does is it opens up that window so that you can not only play around and improve the solder joint performance, but you can have that, and in this case, eat your cake too, because now you can drop down in temperature to improve not only your process efficiency, but also the energy consumption right there and then.
Yeah. And like you say, it's only been 3 years, but it seems like it's catching on. How do you see the future? How do you see this rolling out and developing?
So there are many changes in technologies going on right now. I'm very excited about a couple of applications looking in to have it combined in this case with some other sustainability related technologies, such as in energy storage and electric vehicles. We have some evaluations ongoing. That's really symbiotic relationship here. In addition, the other places I see are large server boards and industrial equipment that needs that open door for both their process capability and now understanding where they can save.
Yeah.
So that's where I see ourselves taking the world by storm. I think there's a lot of opportunities, not only for Indium, but a lot of manufacturers, once they understand that this will change the designs they can build. It'll change the components they can choose. So up until 2 years ago, they were designing and building with the assumption they had the option of either SAC 305 or bismuth tin. They didn't know there was something available that would give them the ability to reflow at 210 and have these other capabilities and other performance metrics. Now they're working with us. There'll be changes, and I look forward to that. Not to mention, I mean, we're not done with our development either, right? We didn't get rid of all of those smart R&D people just because we had one good product come out the door, right?
Right. And that's it, right? I mean, it's always staying ahead of the industry and engaging with them, as you sounds like you do naturally there at Indium, and then come up with the solutions that the industry really needs.
Yeah. So I just want to quickly, get through that. Low temperature solder isn't a one and done. We're still working on it and trying to keep improving. I think Durafuse is extra exciting because it's not a incremental difference. I think it's a major step change in performance, but there are still improvements coming through that we'll be sharing and working with our partners on in the years to come. In addition, we are looking internally at ourselves for sustainability and improvement, and helping our customers for things like packaging, both improving our own process and making it better for customers that have how many jars and boxes coming in every day, to even improving and keeping track of our source materials, because as this process keeps going through the stages of scope 1, 2, and 3, we'll be prepared to not only help provide these solutions for their process, but also have the information and the source materials that are sustainable and looking to the future as well.
Yeah, and it strikes me, I've interviewed your colleague, Brian O'Leary of Indium before, who focuses on the EV and the infrastructure part. And one of the issues that he always raises is that these systems are always on now, right? That adds so much more strain to the system. And so that solder is being constantly being called upon, so to speak, right? And being leveraged.
And new challenges too, because now it not only has to be ultra reliable in some of those cases, but now it has to be just as complex and dense and as cutting edge handheld technology or our computers. So that adds a new type of reliability requirement, where previously you could just build in bulk to maybe account for some of those mechanical challenges. And that's not happening anymore. So I won't get too distracted, but for people interested in high reliability, a Durafuse LT is a very impressive product, not only for low temperature, but also is compatible with some very fine pitched components and helping improve the reliability in this space that doesn't give you a lot of material to work with.
Yeah, no, well put, well put. You are a great spokesperson for this product, I must say. You have a real enthusiasm and clearly an encyclopedic knowledge of what you're talking about there. So I've enjoyed this very much. You're a great interview. So I hope we can do this again and maybe get some catch-ups, because like you said, you're on the beginning. It's only a couple years in, and it will be evolving. It will be improving, and more data will become available, right?
I very much look forward to keeping you updated on some exciting projects we have ongoing right now. As I said, there's the first main one may have been in some of the mobile technology, but both electric vehicles, energy storage, and in the industrial space, when you talk with Brian, I think there's large movements and great interest in taking advantage of what this new technology has to offer.
Yeah, no, absolutely, absolutely. Well, Claire, thank you for your time today. Thank you for sharing with our audience. Like I said, you're a great interview, and hopefully we get to do this again because you're a good spokesperson.
Thank you very much. I appreciate your time and look forward to chatting with you again.
Excellent. Thank you, Claire.